Hi, I'm going to show you how to draw a principal ray diagram for an object outside the focal point for a biconvex or converging lens. So the source of light when we're dealing with lenses or mirrors is called the object. And in this case we're placing the object outside the focal point. Okay, and there's actually two focal points because parallel rays from this side would converge to here, parallel rays from this side would converge to here. And I want to roughly predict the location and properties of the image using what's called a principal ray diagram. So probably the most intuitive one is to draw what's called a P ray. So a P ray is parallel to the principal axis. So the principal axis is a line connecting these two dots. And so we're going to consider the top of the person's head to be the source of light in this case. So you can pick anywhere in that person's body, but I think it's kind of easier if we deal with one end. So I'm going to look at the top of the person's head. There's an infinite number of rays that come off of that person's head, but we're going to consider the one that happens to go parallel to the principal axis. And so I draw the line to the dead center of that lens. And of course it's going to bend twice, but in these principal ray diagrams we simplify a little bit and just draw one big bend in the middle of the lens instead of showing two small bends at the surfaces. And so that one, by the definition of the focal point, will go through the focal point. So I just draw it through, and I don't make it stop there, I just keep going because we don't know what the rest of the rays are going to do. Okay, so there's our P ray. And then kind of the opposite of the P ray is the F ray. So parallel ray goes parallel through the focal point. The F ray goes through the focal point and comes out parallel. It's just the reverse. So my F ray, I go through the focal point from the same source, hit the lens in the middle, and representing two small bends, I draw a ray coming out parallel to the principal axis. So just the opposite of the P ray. Okay, so there's my F ray. And then just to double check your work, two rays is enough to triangulate the image, but just to double check your work, you can draw one through the center of the lens. I need a longer meter stick. It's a yardstick, but whatever. So I go through the center, and that's going to divert just a tiny bit, but basically it passes through more or less unimpeded, and it goes through, and I missed just a tiny bit, but I know that somewhere around here would be the location for the image for the top of the person's head. And then I can take and extrapolate to the rest of the person's body, and I get something like that. Okay, and so that is my image, and I can make a few observations here. I can assert that it is inverted, and I can also call it real. Okay, and what we mean by a real image is that these light rays do converge to that point. The light rays actually go there, and so it is a real image. It's upside down, inverted, because I located the image on the opposite side of the principal axis as where the source of light, the object, was. And then I can also observe that it looks like it's about the same size, and that's going to be true if the object happens to be at a distance twice the focal length, which is about what I drew. So that's not terribly surprising either. But you can estimate whether it's bigger or smaller, and maybe even get out your ruler and measure it to get a magnification based on the principal ray diagram. Okay, so that's it. I've got a few other videos with different scenarios, different types of lenses, different locations, and maybe you'll take a look at those as well. Thanks for watching.